You may have seen this image, a jagged spike of rock rising thousands of feet from the surface of a moon, as if the ground had cracked open and something sharp had forced its way out. It has appeared in dozens of videos and articles about Jupiter's moon, Io. It looks alien, dramatic, almost impossible, and it is exaggerated. The image is an artist's concept, created from Juno data but stretched far beyond what the data actually shows. The real feature, officially named Dis Mons, nicknamed Steeple Mountain by the Juno team, stands between 3 and 4 miles tall, still enormous, still unlike anything on Earth. But not the razor-sharp spike you may have been shown. What created it, however, is far more interesting than any illustration. Because Steeple Mountain was not built the way mountains on Earth are built. There are no tectonic plates on Io, no continents drifting into each other over millions of years. Instead, Io's mountains are pushed upward by something happening. Beneath them, the relentless pressure of a crust being buried by its own volcanic output. New lava flows spread across the surface continuously, burying older terrain. As the old crust sinks under the weight of fresh material, it compresses. And when the pressure becomes too great, massive blocks of rock are thrust upward through the surface. Mountains on Io do not grow slowly. They are forced up, like splinters being pushed through skin by pressure from below. The result is structures that look nothing like the rounded, weathered peaks of Earth. Isolated, steep-sided, and enormous. Io holds more than 130 named mountains, averaging over 20,000 feet in height. The tallest, Bousal Montes, stands at roughly 57,000 feet, nearly twice the height of Everest, on a moon with no wind and no rain to erode them. And the force behind all of this is the same force that powers everything on Io. Io is the innermost of Jupiter's 4 large moons. It is roughly the size of our own moon, about 2,200 miles across. It orbits Jupiter once every 42.5 hours, closer than any other large moon to its planet. And it is locked in an orbital resonance with 2 of its siblings, Europa and Ganymede. Every time Io completes 2 orbits, Europa completes 1. Every time Europa completes 2, Ganymede completes 1. This pattern keeps their orbits slightly elliptical rather than perfectly circular, and that small eccentricity has enormous consequences. As Io swings closer to Jupiter and then farther away on each orbit, the gravitational pull changes. The difference is enough to flex the entire body of the moon. The solid rock surface rises and falls by roughly 330 feet every orbit. Not water, not atmosphere. Solid rock, bending like a tide, every 42 hours. The friction from this constant flexing generates heat deep in Io's interior. Enough heat to melt rock. This is called tidal heating. And it is the reason Io has nearly 400 active volcanoes. How do you get 400 volcanoes on a moon the size of ours? You put it next to the largest planet in the solar system and let gravity do the rest. For decades, scientists debated what Io looked like on the inside. One hypothesis said the tidal heating had melted so much of the interior that a global ocean of magma existed just beneath the crust, a continuous layer of liquid rock wrapping around the entire moon. If that were true, the crust would be thin, flexible, and uniformly hot. In December 2024, a team published the answer in Nature, using data from Juno's closest flybys the year before. By tracking how Io's gravity affected the spacecraft during close flybys, scientists measured the moon's tidal deformation directly. The result was clear. Io does not have a global magma ocean. Instead, each volcano is powered by its own individual magma chamber, a separate pocket of molten rock, heated, independently by tidal friction. Io is not one furnace. It is 400 furnaces, running at the same time, each with its own fuel supply. This discovery overturned a 44-year-old assumption about Io's interior, and Juno went further. By mapping the subsurface temperature for the first time, scientists found that roughly 10% of Io's surface has slowly cooling lava just beneath the crust. The volcanoes, the lava fields, and the underground flows act as a cooling system, moving heat from the interior to the surface, where it radiates into the vacuum of space. Days later, during a more distant flyby on December 27th, Juno recorded something else. A volcanic eruption near Io's south pole so powerful that it saturated the spacecraft's infrared detectors. The energy output exceeded 80 trillion watts, 6 times the combined power of every power plant on Earth. The eruption covered more than 40,000 square miles, roughly the area of Iceland. It was the most powerful volcanic event ever recorded in our solar system. And it was still active 3 months later. If you could stand on Io's surface, which you could not between the radiation, the vacuum, and the temperature swings, what would you see? Imagine it anyway. Beneath your feet, ground made of sulfur and silicate rock. Yellow, orange, red, white, the colors shifting with chemistry and temperature. In the distance, a volcanic plume rising hundreds of miles above the surface, ejecting gas and particles directly into space. When that material meets the vacuum, sulfur dioxide freezes almost instantly, falling back as a fine chemical frost. The surface temperature away from the volcanoes hovers around 200 degrees below 0 Fahrenheit. Near the vents, the lava reaches over 2,300 degrees. Fire and ice separated by a few miles on the same world. And above all of it, filling a quarter of the sky, Jupiter. Silent, enormous. The source of every force that keeps Io churning. What makes Io remarkable is not that it is violent. It is that it has been this way for billions of years, and it is not being destroyed. The surface of Io is completely renewed by volcanic activity every few 100,000 years. Fresh lava covers old terrain at a rate of roughly ½ an inch per year across the entire moon. Craters do not last. Landmarks do not survive. The Io that Voyager photographed in 1979 no longer exists. The surface Juno imaged in 2024 will be gone within geological moments. Io is not a moon that is dying. It is a moon that erases itself and starts over, continuously, driven by the same gravitational rhythm that has been running since the Galilean moons settled into their orbital resonance. And the same process, tidal heating, is what keeps the oceans of Enceladus and Europa liquid beneath their ice. The same flexing that melts rock inside Io keeps water warm inside those other moons. The mechanism that powers 400 volcanoes on one world may also be sustaining the conditions for life on 2 others. Io is not separate from that story. It is the loudest expression of it. Every eruption, every lava flow, every mountain thrust through the crust is the same physics that, in a quieter register, might be keeping alien oceans from freezing solid. The most violent place we know may also be the key to understanding where life can survive. And it has been running this way, uninterrupted, for longer than complex life has existed on Earth.